Alright, welcome back to another algebra class, Algebra 1. Today we are on 6.5 geometric sequences. And yes, we skipped 6.4. Okay, what I'd like you to do is grab a piece of paper and fold that piece of paper in half. Then take that piece of paper and fold it in half again. And just keep folding it in half as many times as you can. See if you can fold it in half more times than I do. Now, a piece of paper is 0.1 millimeter thick. So each time we fold it in half, we're doubling that thickness, right? So folding it in half. Okay. Let's fold it in half again. Ooh, getting to the limits of how many times I can fold it in half. So that's about as many times as I can fold it in half. So let's see how many times I got. I got 1, 2, 3, 4, 5, 6. So I was able to fold my piece of paper in half 6 times. So assuming that piece of paper is 0.1 millimeter thick as a standard. Assuming this piece of paper is 0.1 millimeters thick, each time I folded it in half, it doubled. So each time I folded it in half, it doubled. So I have a increase of 2. So my equation for this would be my starting value, my ratio, and there. So by the time I got to 6 folds, 0.1 to the 6th power, let's see how thick my paper is. So by the time I got to 6 folds, so we'll go in here, we'll say y equals 0.1 times 2 to the 6th place. So we are at that means that at the 6th place we are now at 6.4 millimeters thick. So when I got to 6 folds, we are at that thickness is 6.4 millimeters. So my question for you is, if I were able to fold this thing 15 times, would it then be taller than you? Well, let's check. So my equation would be y equals 0.1 to the 15th place. And what do we get? Well, let's check. We'll take this, we'll take the 6 out, and we'll put 15. And that gives us 3,276.8 millimeters. So 3,276.8 millimeters. Now we know that if we divide it by 1,000, we'll get our meters. 1, 2, 3. So we have 3.2768 meters. That is about 10 feet. If you were able to fold this piece of paper just 15 times, it would reach a height of 10 feet. From that 1 millimeter to that 6.4 millimeters to 10 feet, just between 6 and 10 folds. I'm sorry, 15 folds. So at 15 folds. That is an example of a geometric sequence, and that is crazy. Now we can look at that. We can look at that on our graphing calculator, and here it is. It's getting bigger and bigger, and if you recall, at 6 folds, we were at 6.4 millimeters. So right here, 6 folds, we were at 6.4. So at 15 folds, right out here, it's saying we're at 10 feet or 3,000 . Good heavens. So you can see how steeply it goes up. A geometric sequence goes up. Pretty amazing. All right. So let's go back. Let's go back and check out our workbook. If you see here on page 179, we do the paper folding. 15 times it was in fact taller than us. Wow, that's amazing. All right. How can you use geometric sequence to describe the pattern? Well, it's an exponential increase. It increases greater and greater, or it decreases greater and greater as it goes along. Flip the page 180. Let's go over some vocabulary. Geometric sequence. That is a sequence that changes exponentially. Sequence that changes exponentially by a common ratio. So in that last example, our common ratio was times 2. What is a common ratio? A common ratio is what you multiply by. So in our case, our common ratio was 2 times 2. Now you can times it by 1/2 if you had a sequence that went like 32, 16, 8, 4, 2, 1, 1/2, 1/4. That common ratio would be times 1/2. So it's what the common ratio is what you multiply it by. So let's look at this ratio, or this geometric sequence here. We have 1, 5, 25, 125. So we have a common ratio of 5. We're multiplying it by 5. Now, this is our first, second, third, fourth term. What would be our fifth term? Well, you can do that by just multiplying it by another 5, and you would get the answer. However, I'm going to show you, what if we wanted to find our 20th term, or our 10th term? So I'm going to give you a formula for finding these. So we're going to be looking for our 5th term. And the formula looks a little daunting at first, but once you explain it, it's not that difficult. I'm going to make it a lot bigger so that we could define these. So what we have here is we have, this is the term in the sequence you're looking for. Term in sequence you are looking for. So in this case, we're looking for our 5th term, i.e. our 5th term equals a to the 5th. Okay? This is our first term in sequence. So in this case, our first term is 1, i.e. 1. It will not always be 1. In this one, it happens to be 1, but it's not always 1. R equals our common ratio. And in this term, our common ratio is 5. And then n minus 1 is, you're looking for the 5th power. You would have, this is your n value, right? So this is your number you're looking for. minus 1. So in this example, it would be 5 minus 1, or 4. So for this, our a to the n, so we're going to do a to the 5th equals our first term, which is 1, times our rate, which is 5, n minus 1. 5 minus 1. So we have 1 times 5 to the 4th power. And if we do 5 to the 4th power, we get 625. That's our fifth term. Our fifth term, a to the 5 equals 625. What if you wanted to find your sixth term? Sixth term. Well, our sixth term would be a to the 6 equals 1 times 5 times 6 minus 1. 1 times 5 to the 5th power. So you would get 3,125. We just plugged it in here. Make sure this is written down clear as day, because we are going to refer to this throughout this geometric sequencing. Okay? We're going to turn this unit into two parts. So today we're just going to go over a bit. We're not going to really get into the graphing part of it. So let's look over here at page 181. Determine whether the sequence is arithmetic, geometric, or neither. Explain your reading. Now don't forget, arithmetic, arithmetic is linear. It has common number added or subtracted, which is linear. I should have left more room, but so that's arithmetic. And then I'll use a different color. And then geometric. So geometric has common multiplication. Excuse me. Common multiplication. So let's check and see if these have common multiplication. Which, don't forget, that could be times 2, that could be times 4, times 10, whatever. Or it could be times 1/4, times 1/2. That's multiplication. Or if it's arithmetic, it's linear. It has plus or minus. So let's see. From 1 to 4, we have, to negative 4, we have minus 5. And then we have a plus 20. So it's not linear. It's not arithmetic. 1 to 4, we have times negative 4. Negative 4 to positive 16 is times a negative 4. 16 to negative 64 is times a negative 4. So this has a multiply of negative 4 each time. So this is a geometric. Geometric. And make sure you check each one of them, because it may not be each one of them. So here we have plus 4, plus 4, plus 4. So this is plus 4, plus 4, plus 4. So this is linear. Okay. 2 to 4, that's plus 2. 4 to 8, that's plus 4. So that's not plus. So 2 to 4, that's times 2. 4 to 8, that's times 2. 8 to 32, oops, that's times 4. So this one is neither. So that's why it's important to do each one of them, because ding, 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 we don't have a common ratio. Okay, go ahead and try 4, 5, and 6 and see how you do. And Here we have in exercises 7 through 9, write the next 3 terms of the geometric sequence and write the equation. So let's look at this. Number 7, find a common ratio. So we know these are geometric sequences, so we can just look for the common ratio. 7 to 21, that's times 3. 21 to 63, that's times 3, times 3. So our ratio equals 3. So our equation is going to be, write the next 3 terms. First I'm going to write the equation. So a to the n equals our first term times our ratio to n minus 1. You know, I'm just going to write it here because here it is. A to the n equals a to the 1 times r to the n minus 1. So there it is right there. So let's find the next 3 sequences. Whale, this is our first, second, third, fourth. So our 5th term is 7 times 3 to the 4. So I'm going to go in here, and I'm going to go 7 times 3 to the 4th power is 567. How about 7 times 3 to the 5th power? So that's our next one. So I go in here, and I go 5. That's 1701. And then I go to the 6th power, and I get 5103. So I wrote the equation. Right here. And then all I did was I plugged it in, and I got, there's the next 3 terms. 1, 2, 3, the next 3 terms for here. So let's check this. Number 8, 576. That would be times 1/2, times 1/2, times 1/2. So go ahead and plug those into your equation. A to the n equals, and fill it out. And then find your next 3 terms. Number 9, that would be times and negative 2. It's times and negative 2. Times and negative 2. So there's your rate. Your common ratio is negative 2. And here's your equation. So go ahead and write your equation for that. Alright, finish that off 1 through 9. We're going to deal with the geometric sequence with graphing tomorrow. So go ahead and finish 1 through 9. Make sure you go and watch the Khan Academy. That's on, watch the Khan Academy that is on the module, and then do the few problems that are on the worksheet. So watch Khan Academy and take a picture of the examples that he gives. That's part of your credit. All right? Have a wonderful afternoon. Give me a call with any questions.